Hey guys, welcome to question MM342 of the Maths Methods Fortify study guide. So in this question we've got the graphs of y squared equals x, so this graph here, and y equals 2x plus b, where b is less than 0, are shown below for the domain x from 0 to infinity. Now, the first part says find in terms of b the coordinates of points p and q, the points of intersection between the two graphs. Alright, awesome. So, as always guys, whenever we deal with points of intersection, what we're going to need to do is actually make them equal each other, right? So, we know that y is equal to 2x plus b, and y squared equals x. So we know that y is equal to this, so we can actually sub this into our y value, because all we need to do at the end of the day is just get all x's and kind of cancel out our y's. So what we're going to say is that 2x plus b squared is equal to x. Right, so I've just taken that y value there and subbed it into that y there. Now, we basically need to now just solve for x. So let's expand all this out. So we get 4x squared plus 4bx plus b squared equals x. And getting everything onto one side, we get 4x squared plus 4bx plus b squared minus x equals 0. Now, 4bx and negative x are like terms, so I'm going to factorize those. So you get 4x squared plus 4b minus 1x, so 4b times x minus x there, plus b squared is equal to 0. Awesome, now this is our first mark. What we could do, because we have our CAS, we could solve this in CAS and find out what x is, but we kind of need to show what we're doing, right? So we need to show that we know what's going on. So let's do this by hand. I know this kind of sucks, so I apologize for writing this question. How do we solve for x in this context? Well, we can't do normal factorization because that's just way too complex. So what we're going to do is we're going to have to use our quadratic formula. All right. So we know that our quadratic formula says that x is equal to negative b plus minus square root of b squared minus 4ac over 2a. And so now we can sub these in. So our b value is here, our a value, and our c value. So negative b is negative 4b minus 1 plus minus square root of b squared, so 4b minus 1 squared, minus 4 times a, which is 4, times c, which is b squared, over 2a, which is 2 times 4. Awesome. Now what we end up with here is 1 take 4b plus minus square root of 16b squared minus 8b plus 1 minus 16b squared over 8. And then we can simplify that to 1 take 4b plus minus square root of 1 minus 8b over 8. Awesome. Now, that's our second mark. So we've got our two x values now. We've got the plus minus there. But we also need to now find our y values, right? Because we need to actually find the coordinates of p and q. Awesome. So we know that y is equal to, let's just get rid of this. We know that y is equal to 2x plus b, which means that our y values are 2 outside of 1 take 4b plus minus square root of 1 take 8b over 8 plus b, right? 2x plus b. So therefore, our y values are 1 take 4b, or 1 take 4b plus minus square root of 1 take 8b over 4. So we're doing 2 times this, and that cancels out that, plus b. Now, this negative 4b over 4 is the same as negative b, so negative 1b, and then we're adding a b, so those b's actually cancel each other. So what we get is 1 plus minus square root of 1 take 8b over 4. And there are our y values. So then we can say that p is our x value, which means we get 1 take 4b minus square root of 1 take 8b over 8. Now y value for that is 1 minus root 1 take 8b over 4. Awesome. Now, can I fit the next one in? I think I can. Now Q is 1 minus 4b plus square root of 1 take 8b over 8, and 1 plus square root of 1 take 8b over 4. Awesome. Now that is our third and final mark for part AI. I know this is a little tricky, little annoying to do, but this is just the first question. So guys, that's it for part AI. Let's move on to part AII. Part AII is actually quite tricky, and it's another 3-mark question. So a couple of big ones to begin with on this question. So the question asks us to find the area A of the shaded region in the diagram above, or in the graph above, which is this bit here. Now, we've got a weird relation here, y squared equals x, which we're not really used to. So what we actually would probably want to do, there's multiple ways of doing this, but the way that I would do it is to actually get the inverse of both of these, and then find the area on that. And what I'll show you what I mean by that. I'll try and draw it a bit smaller so we can actually deal with this. So the inverse of y squared equals x is y equals x squared, all right? So we get our y equals x squared here. And if you're not sure how to even come to this conclusion to do this, it's just experience, and you'll kind of get to know, the fact that we're not used to seeing y squared equals x should be like a little bit of a telltale to say, okay, you need to find the inverse of it. So find the inverse, which is x squared, and the inverse of y equals 2x plus b is y equals x take b over 2. All right, so now we're looking at this area here, and this is a lot easier to deal with because we've got a point here, which is our P, or I'm going to call this P2, and here, which is our Q2, right? So the reason why this is easier is because in this one, we can say the area between this graph and y equals x squared from P to Q, and that's just kind of one integral that we can deal with. Whereas here, we've got this weird y squared equals x, we're going to have to split this up into 2 areas and then do that. It's a bit annoying, right? Whereas this one is a lot easier. So we're going to do this. Now, because these inverses of each other, P2 and Q2 actually have inverse coordinates. All right, so we know that P2 is the same as P, but just with the x and y values swapped around. So we can say that P2 is 1 take root 1 take 8b over 4. 1 take 4b take root 1 take 8b over 8. And same for Q2, which is 1 plus root 1 take 8b over 4. 1 take 4b plus root 1 take 8b over 4 over 8. Awesome. So there are 2 coordinates. That's this coordinate and this coordinate. So now we can actually say, that's our first mark. So recognizing all that gives us 1 mark. And we can actually say now that our area is given by our integral from P2 to Q2 of our top minus our bottom, dx. Yeah, do I have enough room there? Yes. No, probably not. So I'm not going to leave this here. I'm going to get rid of this. So if you need it, just pause the video now and just take a look at it and maybe even draw it yourself, just so that you can have it there. So let's get rid of all this. Sweet. So that means that our area is going to be equal to, from P2, which had an x value of 1 minus root 1 take 8b over 4, and Q, which had an x value of 1 plus root 1 take 8b over 4. Awesome. Of our top function, which was y equals x take b over 2, minus our bottom function, which was x squared dx. This is our second mark. Now we can say, I would go one step further and say that this is then x squared on 4 take bx on 2 minus x cubed on 3, from 1 take root 1 take 8b on 4, 1 plus root 1 take 8b on 4. Awesome. And then what I'll do is actually just simply plug this into my CAS and get the final answer. So then we can say that our area is 1 over 48 minus b over 6. So out of 1 take 8b units squared. And that is our third and final mark for AII. I know this is a really disgusting answer, but sometimes you're just going to get these and you're just going to have to deal with it. So guys, that's it. If you have any questions about that part, let me know. But let's move on to part B. Now part B is a 2-mark question, so we're getting a little bit simpler, but this does rely on the fact that you find out what the area is in part A, right? So part BI is 2 marks, and it asks us find the range of values of B correct to 3 decimal places for which A is greater than or equal to 2. So for which our area is greater than or equal to 2. Now in the previous part, we found that A was equal to 1 over 48 minus B on 6 root 1 minus 8b. And therefore, if the area is greater than or equal to 2, then this must be greater than or equal to 2. Awesome. That's our first mark. So if you figure this out, like if you figure out that this is the area, this is actually a really good question because you can get 2 marks, not easily, but simply if you kind of realize what you need to do. So that's our first mark, and then we would just sub that into CAS and solve that. So CAS B is less than or equal to negative 2.496, and that's our second mark. So guys, that's it for part BI. It's really just using your calculator and realizing you have to get this equation and sub that in. So that's it. Let's move on to the next one. Now part BII is a 1-mark question and relies really heavily on the previous part. So part BII, 1 mark. So it says find the range of values of B correct to 3 decimal places for which A is less than 2. Cool. So in the previous part, we found that for A is greater than or equal to 2, B is less than or equal to negative 2.496, right? Which means that for A is less than 2, B is the opposite, essentially. So B has to be greater than negative 2.496. But we're not done yet, because the question tells us that B is less than 0, right? So B is less than 0, which means that we have to find the intersection point between these two, which means that if it's greater than negative 2.496 and less than 0, that's our answer. So it's greater than negative 2.496 and less than 0. So guys, that's our final answer for part BII. If you didn't say this and you only left it as this, you would be incorrect, unfortunately. So that's that one. Guys, that's it for part BII. Let's move on to part C. Part C is a 2-mark question. And it says a value for B is chosen such that Q lies on the point AA, where A is a positive real constant. Find this value of B and state the value of A. All right, awesome. So we know that Q is at AA in this section, which means that our X value is the same as our Y value, right? Because if it's at AA, both of these are the same, which means that X equals Y, right? That makes sense. So Q, we know, lies on Y squared equals X, right? If Y and X are the same, we can actually say that Y is equal to X here. So we can sub in our X value for Y, right? So because these are the same, we can substitute one in for each other. And then from here, we can say that X squared minus X is equal to 0. Taking X out as a common factor, we get X outside of X minus 1 equals 0. So therefore, X equals 0 and X equals 1. But the question tells us that A is a positive real constant, X is greater than 0, so therefore X equals 1, and therefore A equals 1. Awesome. That's our first mark. So we've found the value of A, we've stated that value, and now we also need to find the value of B, okay? So we know that Y is equal to 2x plus B, and we know that this point Q is now lying at 1, 1, right? Because we found that A was equal to 1, which means that 1 is equal to 2 outside of 1 plus B. 1 equals 2 plus B, so B equals negative 1. That's it. That's our second mark. So A equals 1 and B equals -1 in this case, guys. That's it for part C. Let's move on to part D. Part D comes back to our area function. So this question is difficult in the sense that it relies on you getting the area quite early on. And if you can't do that, it does make it very difficult. So if you're not too sure about any of these, just look at the area formula in the answer that I've given, and you'll be able to kind of work it out from there. So part D says if B equals -2, what is the area of the shaded region A? Awesome. So we know that the area is given by 1/48 minus B on 6 outside of root 1 take 8B. And we're saying that B is -2. So our area is 1/48, take away -2 on 6 outside of 1 take 8, -2. Now what this gives is 17/48 times 16, 1 plus 16, which gives us 17√17/48 units squared. Now this didn't ask for decimal places, so we need to make sure that we just do it in exact value. But that's it. So that's our first and only mark for part D, and that actually wraps up MM342, guys. If you have any questions, as always, please hit me up in the comments below. But otherwise, thank you for watching, and I'll see you in the next video.